Standard 10th Science and Technology Part 1st, Chapter number 2, Periodic Classification of Elements. Now we are going to deal with the modern periodic table. This is also known as long form periodic table. Why this is called, that we will see afterwards. First of all, the modern periodic law, which was stated by Henry Moseley, is properties of elements are a periodic function of their atomic numbers. Now, I request all of you that for the study of this part, everybody should take their textbook and open the chart of the modern periodic table and observe them properly. The elements, the groups, these various types of patterns are shown here that you have to observe keenly. And now we will show the parts. This is nothing but a PDF from the textbook. Okay, now I want to know how many vertical columns are present in this periodic table. Please search. You will find that this is the first vertical column, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So there are 18 vertical columns, and these 18 vertical columns are known as groups. That means this is group number 1, this is group number 2, this is group number 3, this is group number 4, like this. And these numbers are shown here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 18. Okay, and how the elements and their information is shown in this table in every cell. That information is given here: atomic number, symbol, name of the element and atomic mass, that is written at the base level, like this. Then you can find out horizontal rows. How many horizontal rows are present in this table? Please find out. You will find there are 7 horizontal rows are there. These 7 horizontal rows are known as periods. That means this is period number 1, period number 2, period number 3, period number 4, 5, 6, 7. That means these are the 7 horizontal rows are there, and each row is called a period. Period number 1, 2, 3, 4, like this. Okay. Now, what are the periods? In a single period, elements are present. This period shows that period number 1 shows the electron shells, number of electron shells. That means in first period, 1 electron shell is present only. In the next period, the first electron shell is completed here in the first period. After completion of that period, then new shell starts with filling the new electron shell from left to right. Again, up to this element, the next electron shell is again completely filled, and after that new shell starts from this sodium. Again it is completed, again next period will start. That means period is number of electron shells present in the atom. Okay. Now, please once again find out in period number 2. So I have written these number of elements. In period 1, 2, 3, 4, 5, 6, 7, 8. So here 8. In period number 3, how many elements are present? 1, 2, 3, 4, 5, 6, 7, 8. So it is written here. In period number 4, how many elements are present? 18. Period number 5, 18. Period number 6, one should write 18, but here 32 are written. Why? Because at this place, at Z is equal to 57, that is lanthanum, and from this lanthanum and afterwards there are 14 elements are added in this, therefore the in all total value will be 32. Next, in period number 7, here the Z number is 89, that is of actinium. After that 14 elements are present in this horizontal plus 14, 32. Likewise, in this period also the number of elements is 32. Now, at this place, that means in the group number 3, period number 6, the element which is present is lanthanum, and after that, that means atomic number 58, 59, 60, like this up to 71. All these elements will show similar chemical properties, and these are placed at this place, and they are coming after lanthanum, therefore they are known as lanthanides. First series is lanthanides. And here in group number 3, period number 7, after atomic number 89, that of actinium, all the others are known as actinides. These are again showing similar chemical properties with that of the group number 3rd elements. These are known as actinides. This is the general structure of the modern periodic table. Now, here some colorful patterns are shown like this. This is group number 1. In this group number 1, hydrogen is represented in a different shade, and lithium, sodium, potassium, rubidium, cesium, francium, these are represented in another shade. These are all alkali metals, but this is not a metal. This is a non-metal, hence represented in blue shade. Now, you can identify the blue color here also. These are the non-metals. This is also a non-metal, but it is put in this group. Now, this is group number 2. These are all again showing or shown in different shade. These are alkaline earth metals. What is the meaning of alkaline earth metals? That we will see in next part. This group number 3 to group number 12, these are all shown or represented by the yellow color. These are totally different and they are resembling with each other. More or less they are resembling with one another. Then next is group number 13. In this group number 13, this is boron. It is a metalloid. Aluminium, which is a metal. Gallium, like this. Metalloid, metal, and all the others are metal. Boron, silicon, arsenic, antimony, tellurium, polonium, astatine. These are metalloids. They will show properties of both metals and non-metals. And to the right side of this zigzag line of metalloids, all the elements are non-metals. But this group, 18th group, is of inert gases or inert elements. Helium, neon, argon, krypton, xenon, radon, like this. And these are totally inactive and therefore are called as the noble gases or inert gases. And these two rows are shown differently. Suppose these two lines are fixed at this place, then from this position the entire periodic table is shifted up to 14 units, and then this modern periodic table gets elongated horizontally, and as due to this structure the modern periodic table is considered as long form periodic table. That means in this periodic table for every element there is a special placement. We can place all the types of elements in a fixed manner. This is the structure of modern periodic table.